Beneath the waves lies a world that defies everything we think we know about Earth. A realm older than mountains, darker than night, and more mysterious than space itself. We call it the deep sea, but that name hardly captures what it truly is. It is Earth's oldest wilderness, a universe beneath our own, and after centuries of exploration, we still do not understand it. For all our satellites and space missions, for all the probes we've sent beyond our planet, more than 80% of our oceans remain completely unmapped, not unseen by humans, but unseen by technology itself. At the surface, sunlight dances, waves shimmer, and life teems. Drop just a few dozen meters and the world begins to change. Colors fade. Reds vanish first, then oranges, then yellows, until even the brightest light dissolves into blue. At 200 meters, we cross a boundary into a place where sunlight can no longer fuel life as we know it. Plants vanish. Reefs dissolve into shadow. All that remains is the slow fall of particles from above, dead plankton, fish scales, and the drifting fragments of life. Scientists call it marine snow. To us, it looks like dust. To the animals below, it is food, fuel, and survival. Creatures in this twilight realm have evolved to live on scraps. Many are transparent, ghostly bodies drifting through endless blue. Others glow with their own light, painting the darkness in steady pulses and quick flashes. Bioluminescence is not a curiosity here, it is the rule. Some species flash to confuse predators, some glow to attract prey, some emit eerie patterns that might be signals, warnings, or mating calls. We do not yet know. In a place where seeing and not being seen decide life or death, invisibility becomes a strategy. Animals use glass-like skin, mirrored scales, and perfectly matched counter-illumination to erase their silhouette against the faint glow from above. They make light to hide in light, a trick so elegant it reads like poetry, and so useful it shaped whole branches of evolution. Each night, when darkness falls above, the deep sea rises. Billions of animals, lanternfish, squid, jellies, stream upward in the largest migration on Earth. They climb toward the surface to feed under cover of darkness, then sink back at dawn. This daily movement is greater in biomass than all the migrations of land combined, and we discovered it only by accident during World War II, when sonar operators detected a false seafloor that rose and fell with the sun. It was not the bottom, it was life. Past 1 kilometer, sunlight dies completely, and we enter the midnight zone, a place of endless night where pressure crushes steel and temperatures hover just above freezing. Here, life takes on forms that feel invented rather than evolved. The dragonfish carries a private flashlight of red bioluminescence, a wavelength invisible to most other creatures, allowing it to search for prey without revealing itself. Other fish cloak themselves in ultra-black skin, absorbing almost all light so that even a direct beam makes them seem to vanish. Predators hunt by sensing minute vibrations. Prey survive by becoming shadows. In this world, energy is the currency, and every adaptation is about using less of it. Not all deep animals are hunters. Many are scavengers, waiting for a rare treasure, a carcass falling from above. A single whale sinking to the deep becomes an oasis that can feed entire communities for decades. First come sharks and hagfish, then armies of amphipods, and eventually bone-eating worms that strip the skeleton clean, running ecosystems on the oil stored within bones. A whale fall creates life where there was none, an island of abundance in a vast desert of mud. At 4 kilometers, we reach the abyssal plain, an endless flat world of silt that covers more of the planet than any forest or desert. Temperatures hardly rise above freezing, light is absent, and food is scarce. Life here is slow and strange. Many animals live long and reproduce rarely. Some of the largest deep-sea organisms appear in these lonely wastes: giant isopods the size of puppies, amphipods longer than a human hand, and the colossal squid thought to roam the dark. Scientists call this deep-sea gigantism. The reasons are debated: reduced predation, energy-efficient body plans, and cold temperatures that favor larger size are all possible explanations, but no single answer satisfies every case. Beyond the plains, tectonic forces carve trenches that descend into the Hadal Zone, named after the underworld. These are Earth's deepest scars, plunging past 6,000 meters, and the Mariana Trench reaches nearly 11,000 meters below the surface. Conditions are nearly incomprehensible. Pressures exceed 1,000 times what we experience. Temperatures remain near freezing, and darkness is absolute. And yet, life not only survives, but thrives. Fragile, gelatinous snailfish inhabit the trench bottoms. They lack rigid bones and possess cellular adaptations that keep proteins functioning under crushing force. Amphipods swarm across the sediment, and alarmingly, scientists have found plastic fibers inside them, proof that human pollution reaches even the most remote places on Earth. Along the walls of trenches and mid-ocean ridges, hydrothermal vents create ecosystems that run on chemistry instead of sunlight. Superheated water spews from cracks in the crust, rich in hydrogen sulfide, methane, and dissolved metals. Microbes at these vents feed on chemicals in a process called chemosynthesis, forming the base of a food web that supports clams, tube worms, crabs, and entire communities built from heat and rock. These vents revealed a profound truth: life can be powered by the planet itself. If ecosystems thrive around boiling toxic plumes on Earth, then worlds beneath ice, moons like Europa and Enceladus that hide oceans warmed from within, could host life too. Despite powerful submersibles and remote vehicles, what we know of the deep remains fragmentary. For every species we document, scientists estimate dozens more remain unknown. Many deep-sea creatures disintegrate the moment they are brought to the surface. Others change shape under pressure release, or glow in colors undetectable by our instruments. Nearly 75% of deep-sea animals use bioluminescence, but the chemical pathways, evolutionary histories, and ecological roles of those lights are still poorly understood. Why do so many species evolve transparency or ultra-black skin? Why do some grow into giant sizes while others shrink into translucent whispers? These are not small questions. They are puzzles that touch on the fundamental rules of life. The deep sea is not an isolated museum of oddities. It is connected to the surface in ways that matter for the whole planet. Vertical migrations move carbon and nutrients between layers, sustaining fisheries and influencing global climate. Microbes in sediment recycle elements that travel through food webs. And human actions, from plastic pollution to deep-sea mining proposals, reach into these hidden realms with consequences we can barely predict. For centuries, people imagined the depths as lifeless voids or monsters' lairs. What we have found instead is resilience and creativity. Life that bends, reshapes, and reinvents itself to endure extremes of pressure, cold, and starvation. Species that make light to hide, that fuse bodies for reproduction,
that live off chemical energy and boiling plumes, and that can survive for centuries in slow-motion worlds. Every dive, every ROV expedition brings back sights that challenge our definitions: translucent fish, glowing worms, jellies that rewrite anatomy, and microbes that run metabolisms unknown to science. Yet for all we have discovered, the deep sea remains a realm of questions. More than 80% of the ocean is still unexplored. Every descent promises not a single rare find, but a cascade of unknowns. Perhaps the greatest lesson of the deep is humility. Space may be vast, but the oceans that cover our planet hold mysteries closer to home. Secrets that remind us how little of Earth we truly understand. Protecting these places is not just about curiosity, it's about stewardship.